Hello students, now we are going to deal with the most important reactions that are electrophilic substitution reactions, and in this module we are dealing with bromination. Now, before starting with the entire reaction concept, let's first understand how an electrophilic aromatic substitution reaction occurs into amino compounds. Now, if we consider aryl amines, then we have something like aniline. Now students, remember, this compound is a bifunctional compound. What do we mean by this? Bifunctional compounds are nothing but they have two functional groups. That is, one is amino group and the next one is the benzyl group. Amino, he would always show the reactions of amine, whereas benzene would always go for an electrophilic substitution reaction. And now we need to know that all the amines, that is primary, secondary or tertiary amines, are strong activating groups. What do we mean by strong activating group? Let's revise once again. Now, therefore, what we would say, if we have an aniline molecule, this aniline molecule would undergo a resonance effect. And what would happen because of this? Lone pair would get shifted towards the carbon-nitrogen bond, and now the double bond would be shifted onto the carbon atom. We would get a structure something like this, belonging to the first canonical form. This canonical form would further get converted into a second canonical structure, which would be something like this. And finally moving on with the third canonical structures, which would be a structure something like this. And finally, we would get our original structure back. Now, here comes a very, very important point, which we need to remember once again, that in all of these cases, the negative charge onto the benzene ring is only present at the ortho and para positions. That means electron density is very, very high over there, and only those positions would be the highly preferred positions for electrophilic substitution attacks. Now, let's further understand what are the types of electrophilic substitution reactions. We have three types of these reactions. The first one, bromination. The next one is nitration, and the third one which comes is the sulfonation reaction. Let's start with the first, that is bromination. Now, what is bromination? The bromination is nothing but the substitution of bromine. So removing one hydrogen, we would add a bromine into the compound. Let's do this thing. Now, for this, let's take an example of aniline. What we are going to do with this aniline is, we are adding Br2 into this. Aniline is an orthopara activating group. Therefore, we are bound to get a compound which would be nothing but a mono-bromo derivative. That is, H from the ortho position would combine with Br, giving us HBr, and therefore we would now get a compound that would be ortho-bromo-aniline. But they are strong activating groups, and thus the reaction would not stop at a monobrominated level. It would proceed further and go on with the tri-bromo product. Let's see how. For this, we would require 3 bromine molecules. Now, 2 hydrogens from the ortho positions and 1 hydrogen from the para position, all would be removed, and we would get a compound that would be a tri-bromo derivative. And this tri-bromo derivative would be referred as 2,4,6 tri-bromo aniline. So, we got a tri-bromo compound, but the problem is here that suppose if we only want a monobrominated product, then what do? Let's try on with this. We take a compound that is aniline once again. Now this aniline is treated with acid anhydride in the presence of pyridine. So now what do we have? Let's see. Hydrogen and one C double bond O CH3O combines together, giving us a molecule of acetic acid. Now what do we have? We have a benzene ring attached to NH, which is attached to C double bond O CH3, right? Moving on. Now, the entire group, that is an acid analyte compound in which the NHC double bond OCH3 group is an activating group, but it is not a strongly activating group like NH2, and thus we would now say that whenever we have a weak activating group, it would only prefer monobromination. So now what do? We take a weak activating group. Why is it a weak activating group? Because there is a resonance happening inside that compound, something like this. Because of this, what now we have? Let's treat this acid analyte with Br2. Now, bromine would capture one hydrogen from the para position and get converted into HBr, leaving one bromine atom vacant. Now what would happen? All the acid analyte would combine with that bromine atom, giving us a para-bromo derivative. Now, whenever we hydrolyze this compound, what happens? Let's see. Hydrolysis breaks the nitrogen carbon bond. H gets added towards NH. OH is added towards the acetyl group. And because of this, what we now get is nothing but CH3 C double bond OOH, that is acetic acid once again, and we again get an aniline molecule which is reframed. So finally we have arrived at a compound that is 4-bromoaniline or para-bromoaniline. This was all for this module, students. Meet you in the next module. Till then, thank you.